Hello everyone, welcome back to this array series in JavaScript. And today we have one more interesting question. And today's question is that we have to find the longest sub-array with sum equals to k. Let's suppose, for example, if you are given an array is equal to 10, 5, 2, 7, 1, 9. Okay, so this is your array, and k sum is given as 15. So we have to find the longest sub-array possible. So if you see this question, then 10 plus 5, 15. Okay, so I can say the length will be over here 2. Another array possibilities we will check, then uh, 5 to 9, 5 to 7, 7, 7, 14. 1. Okay, so I can see there is one more array possible, this one. Okay, so over here see 5 2 plus 2 7, 7 plus 7 14, 14 plus 1 15. So I can say this will be your longest because 1 2 3 4, so length is 4, isn't it? So what is a contiguous array? Or we have to, obviously we have to tell that contiguous array means the one which is continuous. So it shouldn't be that 10 I take here, 1 I'm taking there. No, it should be continuous. So that's what we have to return. How can we do this? Method one. Very simple approach that first thing that comes in mind is the iteration. What we can do, we can print all the sub-arrays. Print all the sub-arrays. So first we'll find all the sub-arrays, and then we will find the sum of that find the sum of those sub arrays, and whichever sum will be equal to 15, we will return that array. Okay, then after the sum becomes equal to 15, you have to print the longest, right? Then we will find the length of that sub array, and whichever will be the longest, that will be our answer. Okay, let's come to the coding part. Function. Okay, longest sub array, and you are given an input array. And along with this input array, what will be given? Along with this input array, you will be given a number, okay, for which you have to find the longest subarray. Sorry. Yeah, what happened? Oh, okay. Yeah. So initially we will take result equals to 0. We will take result equal to 0. Then what we have to do? You have to start the iteration for let I is equal to 0, I less than array dot length I plus plus. Okay. Now taking array over here. So you are starting from here. Then what you have to do, you have to take all the contiguous array. This, this. Okay. If you take the second element this, then it will go from here, here, here. Okay. So I can say that okay. So first let sum equals to 0. Sum equals to 0. Now we will start a loop for let j. J will start from where? J will start from I, because your contiguous array will start from ith position. So j equals to I. J less than array dot length j plus plus. Okay, now we will find the sum plus equals to a of j. Sum plus equals to a of j. So first we will get mm, let's delete and make it clear. Okay, so suppose this is the array. So this is the first array, second array. No, these all are the sum only. So at each stage we will equate with the k. At each stage we will equate with the k. So let's equate with the k. If sum equals to k, that means we reached our target. Sum equals to k, then we have to find the, okay, so if the sum is equal to k, we'll find the length. So length is will be how much? Suppose your j position is over here, that this from here till here, here to here. So I can say if I is 0, j is 2. So the length will be j minus I plus 1. I repeat, if I position is 0, if I is equals to 0, and over here j is equal to 2, so the length is 3. So I can say 2 minus 0 plus 1. So the length of the subarray will be j minus I plus 1. Okay, but we have to return the longest array. So I can say return math dot max of what? Max of result. Oh, okay, I missed this. Result equals to result equal to. Let me write it properly. Shit, what is happening? Yeah. Okay. So result will be equal to math dot maximum. Maximum of what? Maximum of the result, comma j minus I plus 1. And at the end, what we'll do? We will return result. Or directly we could have return added. Okay. So this is your the very brute force. If I talk of the time complexity, then we are performing a nested loop. So the time complexity will be big of n square. Space complexity, no, we are not using any extra space. Then space complexity will be big of 1. Okay. But we need to optimize this big of n square. Okay. So that's what here comes hashing method, and that is method number 2, hashing method. Okay. To understand this, I'll explain you the first concept. 10, 5, 2, 7, 1, 9. Okay. This was your input array. Now, what is the concept behind this? Concept behind this is we have to find a sum of 15. Okay. Let's take these numbers. If the sum, okay, forget about this 15. If I tell you uh, from here to here, okay, 10, 5, 15, 15 to 17, 17, 7, 24, 24 plus 1, 25. Okay, so from here to here, sum is 15, sorry, 25. From here to here, sum is 25. And we know somewhere, we know that this is the our output array. This is our output array. From here to here, this is the answer that we want. So for this to be answer, which is from here to here, sum is 15. Now we got 25. So if I tell you that for someone to be 25, okay, wait. So for someone to be 15, and if your sum is 25, somewhere if from the starting you are getting 25 minus 15, that is 10. So if 10 is there, then I can say that this array will be equals to 15. Some of this array will be 15. I repeat, let's clear this and I'll try to explain once again. Let's clear it. Okay, let's take this once again. From here to here, the sum was 25, isn't it? Okay, fine. Then if I tell you from here to here, if sum is 25, and I'll tell you that if you get from the beginning, if you get sum as 10, from the beginning, if you get sum as 10, then I can tell you with confirm that this will be equals to 15, isn't it? If from the beginning, if I get that if this is if this is k, and let's suppose the sum is x, then what I want this to be k. I want k minus x. I want k minus x. So if from the beginning I get this k minus x, then with confirmation I can tell you that this will be k. And this from the beginning, whether it is present or not, we will check in the hashing. That's what this method is. We will use hash map. Okay. Let's understand this with the dry run, then things will be more clear. Let's understand with the dry run. Okay. So if let's take a hash map. So the approach is we will loop it, we loop through the array, we loop through the array, we loop through the array, and we will find the prefix sum. We'll find prefix sum. Okay. If prefix sum, if prefix sum is equal to k, if prefix sum is equal to k, that means what? First we will find the prefix sum, then we will check if prefix sum is equal to k. That means directly we got the required array, sub array. Like for example, in the beginning we are doing 10 plus 5, 15. Oh, this is the array. Then I can say the result length will be 2 because 10 plus 5, 15. But if prefix sum is not there, then next condition what we will check? Next condition we will check what is the required sum. What is the required sum? So prefix sum minus k. This is your required sum. That if from the beginning we get this, if from the beginning we get this in the hashing map, in the hash, that means that also will be our answer. Like for example, from here to here we got prefix sum as 25. We got prefix sum as 25. Then this to be 15, we need to check whether in the beginning we had 10 or not. And that beginning we had, that will check our map. That map perform, we will check in map whether 10 is present or not. So if we get 10, that means this is our longest array. So if we get this prefix sum in the hash, if this is present in hash, then again we get our result, and then we will check the length. So now the length will be what? So first we will get the initial value, that this, suppose this is your I, okay, and this is your j. So this we need to subtract. So this is our new length. So the new length will be, new length will be whatever is your initial, whatever is the current index minus from the map, we will get the initial position, initial index. That will be, a new result, a new length. And then since we have to find the longest, we need to check whether this length is greater than this length or not. If the length is greater, if the length is greater, then we will do result equals to math dot max result comma length. Okay, so this is the next condition. Now, if this is not present in the map, if this is not present, then we need to push the prefix sum into the map, prefix sum into the map. So these are the three steps that we will perform. First, we will check whether prefix sum is equal to k, the number or not. If the result sum is equal to k, we'll store the result. If the result sum is not equals to k, then we will find prefix minus k. And then this we will check whether this is present in the hash map or not. If it is present, then we got our new length. So we will length will be I minus the initial index, I minus the initial index, and then we will check whether this your new length is greater than result or not. Once we are done, then we'll push the prefix sum into the map. I hope this is clear. If not, then let's do a dry run, one more dry run, and then I'll explain you. Okay. So your array is your array is 10 5 2 7 1 9. 10 5 2 7 1 9. Okay. Let's take this your hash map over here. Okay. Initially, first prefix sum and k is 15. Okay. Prefix sum. Prefix sum is 10. Is it equal to k? No. Then we will store 10 at 0th position. Next, prefix sum is equal to 10 plus 5, 15. Is it equal to k? Yes, 15 equals to k. Now the result will be, what is the ith position? Ith position is 1, so I plus 1, that is 2. So this is your new array, and here we will store, we got 15 at index 1. Next prefix sum, 15 plus 2, 17. Is 17 equals to 15? No, it is higher. Now we will check whether we have 17 minus 15 equals to 2. Is 2 present in mapping? No. Then we will add 17 at index 2. This done. Now next, prefix is equal to 17 plus 7, 24. What is the required that we need to find? 9. Is 9 present in the prefix? No, it is not. Then we will store this index. Next, prefix sum, 24 plus 1, 25. So 25 minus 15, 10. Is 10 present? Yes, we have. Yes, we have. That means what? Your new length. That means if 10 is present, so I can say this is your new array. So the length will be, what is this current position? I. So over here, I will be 0, 1, 2, 3, 4. 4 minus 0. So new length is 4. Now this 4 greater than 2. Yes, it is greater than, so result will be 4 now. Similarly, now 14 and 1 done. Next, last step, prefix. Okay, so over here we need to store 25 at position number 4. Next, last 25 plus 9, 34. Is it present? No. 34 minus 15 is 19. Is 19 present? No. And then we'll store this 25. So what is the final result? 4. So I hope this is clear. Now let's score this. You can pause this and then you can try yourself because we have discussed a lot. So let's come to the coding part. You know the map operation function, longest subarray. We will be having an input array and a ksum. We have an input array and a ksum. Okay. Initially, we will take let result is equal to 0, and then we need a map also. We need a map also. Const map is equal to new map. So we have map also to store the data, so to store the prefix sum. We need a value prefix sum also. Prefix sum equals to 0. Now we will start the iteration for let I is equal to 0, I less than array dot length plus plus prefix plus is equal to a array of I. So we have prefix sum. We have prefix sum. Now condition, if prefix sum equals to k, if prefix sum is equal to k, then what the result will be? Result will be I plus 1. So this is one condition, I plus 1. Next condition, if it is not, then what we need to say? That if map is having or not having what? Prefix sum. Prefix sum. Please use prefix sum, typing mistake. Prefix sum minus k. So if map is having this, then what? We have our result here also. So result will be math dot maximum. Maximum what? Result comma. We will take the index. We will find that index. So map dot get. Update got of what? Prefix sum. Prefix sum. Okay. So I'll write here. Map dot get of what? Prefix sum minus k, because we need the index of dash only, right? So we got this index, but we need to subtract also with I minus. So this is whichever will be higher, that will become result. And at the end, we need to push if the prefix sum if the prefix sum is not present, then at the end we need to push also. So if map dot has, if it does not having what? prefix sum, then map dot set what prefix sum with the index value. So that's it. This was a very interesting question. And if you're not clear, you can watch this again and you will try to code yourself, write and practice, and things will be more clear. Thank you all. Have a great day. If you are still tuned, like this, subscribe this, and it will motivate me to create more of these videos. Thank you all.